Hello class, this is video 2. We're going to jump into a simple as possible factorial design, not quite simplest as possible, but a simple two-factor analysis of variance where you have two categorical variables trying to predict a continuous dependent variable. We'll use the same data set I used in my one-way ANOVA video on right-wing authoritarianism where we looked at education, which had 4 factors associated with it, but I also have gender in here where folks are called male, female, or other. There were only a handful of others in this data set, so I'm treating them as missing. So it's really 2 factors. So we have what some people might call a 2 by 3 or a 3 by 2 between subjects factorial design, or some variation of that would not be uncommon. So we're going to run that analysis and talk about how to decompose it. I'm going to go quickly, but I want to highlight Fields goes in great detail in his chapter on factorial designs, and he'll go into a lot of the fine print, so to speak, so I encourage you to work through his examples and read it. I want to focus on the concept of probing interaction effects briefly. It's one of the situations where we could jump out to syntax, and he talks about that, and I want to make sure it's clear to you what we're doing. Because you can't get every option some people like through the menu system. Yay. We're going to spend, when we're dealing with analysis of variance in SPSS, we're going to be mostly focused on this category, general linear model, univariate, multivariate, and repeated measures. You can see you can do a lot of analyses through the generalized linear models, which are a more complex topic beyond the scope of the class, nested models and other things like that. But spend a lot of our time right here in the univariate box, which I showed how to use when we were just using education in our one-way analysis. But our dependent variable is still right-wing authoritarianism. Last time we had education, but we're also adding gender to the block. And there's lots of options. You can build custom models, which are actually kind of interesting. In specialized circumstances, but we don't need that. I do like to look at the plots, and so I'm going to, even in anticipation of an analysis, I'd like to plot education, its impact on right-wing authoritarianism, gender. I'd also like to plot potential interaction terms. I put, in this version, I'm putting education on the horizontal axis with separate lines by gender, but it's useful sometimes to look at them both ways, where I swap the order of those, because it's kind of arbitrary. When we dealt with moderation analysis, and you can replicate these analyses with Hayes process, and I'd encourage you to experiment with that to just see if you can get similar results or similar interpretations and go from there. But I've got, did I get that one in there? Oh, no. Again. Gender up here, Add, ask for error bars because we should and can. Hit continue. We also want to see a lot of the means here, so I'm gonna do these, and we can ask it to compare main effects, and we can use a Bonferroni if we want. We'll do that. Under options, I'm going to select descriptive stats and also effect size estimates because we want to see how big these effects are, and let's just see what we get. Okay, here's my output window. It's running. All right, here's our basic summary of the ends associated with each factor for each of our variables. Here's the means associated with every possible combination of our factors with each other. Here's our basic ANOVA table that we would look at typically first to determine do we have any main or interaction effects. And the nice thing about the ANOVA tool that at least the regression tool doesn't do by default, is that it will automatically compute your product term. When we do these in regression, if we're not using the process macro, we have to create the product term, which is a little bit wonky, especially when you'd have to dummy code all of these variables. But in essence, analysis of variance is doing all of this in the background. But you should think about this in the same way you think about linear regression. And a lot of the data is similar. So here we can see that we do have a significant main effect for gender. Now, we don't know what it is just yet. I mean, I could look up here and see, perhaps tease it out with this means table, but there's some difference between men and women on right-wing authoritarianism. Education is significant, and gender, they're both. So we got education levels are making a difference. And I'm also seeing, now this is not traditionally significant at the 0.05 level, but if we're not totally bought into that old framework, which people increasingly aren't, I might still probe to examine an interaction that was less than 0.1 in significance, and this is pretty close to 0.05. But look at the partial eta squares. Remember, this is our effect size estimate, and a partial eta squared is the percentage of variance your factor explains in the DV, controlling for the others. So it's like a squared semi-partial correlation or something like that. So the education, these are small. So these are from 0 to 1. So 0.8% of the variation in authoritarianism is explained by education. 3.3% by gender. And the interaction is pretty small, 0.5, 0.5% of variations explained. But we're going to pretend that that's significant, and we're going to look at it. Now, one of the things, we'll see lots of other data here. Looking at education, we can see now, since that was a significant main effect, we could look for pairwise differences if we wanted to. I can see that there are significant differences between having less than high school and a college degree is significant at the 0.3. That difference of 0.38 is significant. Less than high school is also even more significantly different, with a greater mean difference between graduate degrees. So I can compare any mean with any other, but high school is not less than high school. So that's non-significant, non-significant, non-significant. High school degree authoritarianism is in essence the same, not significantly different than any of the other categories. But as you move towards those extremes, you're seeing them different from each other, and we'll see this in the plots later on. If I look at gender, there is a significant gender effect, which we already knew, okay, from the main effect up here. And remember, when there's only two factors, your F test is basically the same as the independent sample T test. So those means are different. And I'm getting that confirmed here. Here are my plots. So here's the main effect for education. We can see that it appears, and you can look at the confidence intervals, and you kind of see why this one is not different from this one, or this one, or this one. Look at the overlapping confidence intervals, but this one is different from this one and this one. So we can kind of look at it visually to see what it's telling us with the confidence intervals. Here's the gender effect. Women show less, just like more educated people show less authoritarianism. And then I've got two interaction plots where I just plotted them slightly differently, this way and this way. And sometimes it's easier to look at these one way rather than the other. I like this chart, the first one, because it's making clear that this main effect, or this effect of education on right-wing authoritarianism, seems to be an issue for males, but for women, they're largely flat. Education clearly doesn't make much difference. It doesn't appear to. Look at the confidence intervals. It looks like there might be a dip here at the graduate level. These are very flat, then a dip, but these confidence intervals overlap substantially. So to me, that's not a significant difference between graduate education and these others. But for men, I'm seeing this strong trend, and this highlights one of the most important points or common points people make about factorial designs. In the presence of a significant interaction, people usually don't fuss over interpreting the main effects, because look, this main effect, yeah, it is an effect when I average across the men and women, but when I break them out, I can see it's really the men that's driving that. If I were to interpolate the dots at each of these, I would kind of get this chart back. But this chart doesn't make any sense because it doesn't simply reflect truth for the women in the sample, which are basically flat. That's driven by the men. That is the interaction effect. that this in education's relationship with right-wing authoritarianism is based on whether you're male or female. We see it in males, it appears. We don't see it in females. That's our visual kind of test that supports it. This chart plotted the other way to me is messier. I could probably get to the same interpretation. It's the same means plotted differently. But look, I can see that among men with less than a high school degree have the highest level of authoritarianism, but women are basically the same, regardless. Men are, it's just clumsier. All the lines are crisscrossing in kind of weird ways. This one, much more intuitive. Gender appears, I would think, is moderating the relationship between education and authoritarianism. But we still want to test that. So the book, the typical word people use in field use simple effects, or simple main effects, some people will say, is what I really want to do is split this analysis up where I can look at, is there truly a main effect for education? Is education really related among the men and really not related among the women? Because this is one possible pattern. There's lots of possible interaction patterns we could see. Just like we did in regression, the lines could cross or fan out or different sorts of things. But these are clearly not parallel. You're looking for non-parallel lines. Here, these are not extremely parallel. These are not parallel. Evidence of an interaction. You can't get the simple effects analysis from the menu, but you can get it from the syntax. So if I go back to my analysis, univariate, and instead of just hitting OK, I hit paste, it's going to open a syntax window. And Fields will tell you this, but what I'm really wanting to probe is this interaction between education and gender. And if let's say I copy that line, I don't want to, and do it again, for instance, I could add another subcommand, compare, and add, let's say add education here, okay, make sure I don't have a typo, to this, select it and run it again. I'll get the analysis again, but I'll get an extra analysis. If you look for it, you'll see it. And it's basically, you're looking for the one that says simple effects. Here it is. It's just another set of univariate tests. But each F tests the simple effects of education within each level combination of the other effects shown, which in this case was gender. These tests are based on the linear blah, blah, blah. So basically, I've done two one-way ANOVAs, and I could have actually done it that way. It just takes more work. But basically, what I'm saying, for males, the one-way analysis of variance between education and authoritarianism is significant, but among females, it's not significant. So this supports our plot that says these means are the same, but there's differences somewhere among these means. Now, this analysis this F-test tells me that they're there. So now, if I look right here, I see my pairwise comparisons broken up by male and female. And I can see, among males, which of these means are different from each of the other. I visualize that through the confidence intervals, which gives me a similar interpretation. And I can see once again here that college graduates and graduates are the same. And I see, a graduate degree and a high school degree wasn't significantly different. The college degree from the graduate wasn't significantly different. And the college and high school. So basically what I would say is this mean I had fewer graduate students, so the confidence intervals were a little bit broader there. So if I had more of an N there, it would probably be different. But these two are the same. This is different from this, and this is different from this, and this is different from all of them. But this one is technically not different from this one because you can see that confidence interval overlaps too much with this one. So there's more uncertainty around the graduate degrees estimate. But in essence, we're seeing this education effect is reasonably, apparent here. But it's not strong. This chart, once again, exaggerates those effects. And if I correct the scale, which you should always do, it was 1 to 9, apply. This is what we're really seeing. And that's notably less impressive. But that's the effect. It's pretty tiny. Among men, if I go back to that F test that showed the simple effects, because I requested the effect size, I can see that the effect size associated with the relationship between education and authoritarianism among males is 0.014. So 1.4% of the variations explained, and among women, it's virtually zero. So that is a basic 2x3 factorial design with an interaction that we probed through simple effects analysis, but I think the true story is told through the charts. But if I had a significant interaction, I'd probably clean up the chart and promote that. I'd publish the means here and then indicate which ones were significantly different from each other using this table here to provide that evidence in the write-up. Hopefully this was useful.